This is Algebra 2 at Trig, Unit 2B.6. We're going to talk about the remainder and factor theorems. First thing we're going to talk about is to remind ourselves, how would we how are we going to divide a problem like this? Notice we have a polynomial and we're dividing by a linear polynomial. As long as it's x to the first power, and it's very helpful when the leading coefficient is 1, that we can use synthetic division. We can use synthetic division as long as we're working with an x plus a value. So we're going to set that equal to 0, so we know that the 0 value is going to be x equals negative 7. So we're going to use negative 7 in our synthetic division. And if you recall, we drop down the 4. We multiply the first term. This gives us negative 28. Multiply. Multiply. And multiply. That gives us an answer of negative 43. So if we were dividing this out, we would say, since this was x to the 4th power to begin with, this is a coefficient of x cubed. We're dividing out 1 degree, so we're going to lose 1 degree off of x to the 4th. This is going to be x cubed, with this as your coefficient. And a positive 1x squared, and a negative 3x, and a positive 7. And negative 43 over x plus 7. That is our quotient for division. That's our answer of division. So what if, when we're dividing polynomials, the remainder was 0? This remainder was negative 43. What if it was 0? This means that there's no remainder, and it divides into the polynomial evenly. If you get a 0 here, that means it divides in evenly, making it a factor of the polynomial. So if you can get a 0 at the end of the division, so there's no remainder, then you know the value would be a factor. In this case, we did not get a 0, so x plus 7 is not a factor. So the factor theorem says that a polynomial f of x has a factor of x minus k if and only if f of k gives you 0. Recall from geometry that if and only if means it works both ways. So the theorem is also saying if f of k equals 0, and that's what we're going to do, then x minus k is a factor of f of x. We're going to figure out if we have a factor. So we're going to look at this first problem. We're going to factor it completely. Well, it has 4 terms. Normally, if it has 4 terms, we would say 2x cubed minus 11x squared plus 3x plus 36. We would normally say that having the 4 terms, we have to use factor by grouping. That's what we've done up to this point. So we're going to factor out an x squared. That's 2x minus 11 plus 3, x plus 12. We have a problem with this because what's inside the parentheses is not the same. It's not exactly the same, so this cannot be factored by grouping. This polynomial cannot be factored using grouping. It might be able to be factored, but it cannot be factored using grouping. So we're going to look at a different method. What we talked about with synthetic division. We're going to take x minus 3 and equal it to 0. So we're going to use the number 3. And that's going to give us a 2, a negative 11, 3, and 6. Actually, 3 and 36. That's a 36. We're going to bring down our first number, multiply, gives us negative 5, multiply, gives us negative 12, multiply, gives us negative 36. Oh, look at that. We got 0. Now, this is an exciting 0. We're going to put a little smiley face inside that 0. We're going to say 0, kind of like with an exclamation point. So, x minus 3. Be sure you convert it back to the factor. We're not saying x plus 3. We have to say x minus 3. X minus 3 is a factor. Now that's just one of the factors. The question is, how are we going to get the other factors? Well, this was a cubic, and we divided through by x minus 3, and we created these new numbers that are part of a quadratic. So this is going to be 2x squared minus 5x minus 12. There is no remainder. It's the 0. So can we factor that apart? And using a method called guess and check, we know that we've got to have 2x and x, because that multiplies together to give us 2x squared. Now we need to come up with two values on the end that are going to multiply to be 12. We could consider 2 and 6, but that's 12 and 2. That could get us to 10 or 14. We could try 3 and 4. That would give us 8. So let's call it a negative 8, actually, and a positive 3. That would add to be 5. So if you notice, I factored this one using a guess and check format, where I started out with knowing what multiplies to be 2, and considering the different options I have to multiply to be 12. Then you have to actually put them in there and test it out. Negative 8, positive 3, that adds together to give you negative 5. Don't forget, you still have this as your factor, x minus 3. So there we have factored it completely. Notice this does not ask us to solve for x. This is just asking us to factor. So we'll move over to the next one. And we're trying to figure out our factors. So we're going to set this equal to 0 and use the number negative 1. We use our coefficients, 1, negative 6, 5, and 12. Drop down our 1, multiply, multiply, multiply. Oh, goody. It gives us a 0. So we put a little smiley face inside that 0 if you like, because we're excited it's a 0. And we write the word 0 next to it, just to amplify that we're excited that it's a 0. So x plus 1 is a factor. I want to be sure that we totally understand what we just accomplished. Why did we do that? And what did we get from it? Then we use the other numbers to create the quadratic that can be factored, which is x and x, that makes x squared. 3 and 4, that multiplies to be 12, and if they were both negative, it still multiplies to be positive 12, and that would add to be negative 7. Bring down your x plus 1, and you have factored this cubic equation that was not able to use factor by grouping with it. If you can use factor by grouping, go ahead and use that. But most likely, this will be needed. When we find the zeros of a function, it's the same thing. It's the same thing we've been doing with the other types. We're going to factor it, then we're going to set them equal to 0, and we're going to find out what the x value is that makes these 0. Notice the notation. That might be the trickiest part. F of negative 2. Notice that this one is telling you what it takes to get your 0. Negative 2 is the 0 they're telling you. They're not saying that you have x plus 2 equal, just x plus 2. Like they did up here, they said x minus 3, and we had to do the opposite. They're telling you to use negative 2 to produce a 0. So we're going to use negative 2, our coefficients, drop it down, and multiply, and multiply, and multiply, and we're excited to get our 0. So we write 0. So x plus 2 is a factor. Don't make the mistake and call it x minus 2. It would be x plus 2 is a factor. We kind of got ahead of myself on that one. So we're going to say x squared plus 6x minus 7 equals 0. That gives us our factoring opportunity. What times what makes x squared? This is a method called factor by actually guess and check that we're going through to try to figure out what multiplies to be negative 7 and adds to be 6. And of course we're going to do 7 and 1. The larger number is going to have to be positive, and the smaller number is going to be negative. They have to be opposite signs to multiply to be a negative, and the larger number has to be positive for them to produce a positive when adding. So then you do the 0 product property, which gives you x equals 1 and x equals negative 7. Don't forget, you also have your other 0, which is x equals negative 2. That gave us a 0 also. Those are the zeros of your function. If you were going to graph, you would plot a point at 1, at negative 7, and at negative 2. And then with end behavior, you could figure out how it goes through the graph. But here we're just looking for the zeros. So pause the video, try to set this one up, see if you can figure out the zeros of your function. Once you figure out your zeros, run the video and see how you did. So we know that 4 gives us a 0. So we're going to use 4 in synthetic division. 1, 1, negative 16, negative 16. Drop down your 1, multiply, multiply, and multiply. Oh, goody. That gives us a 0. Not a big surprise. They told us it was going to be a 0. But it's nice to see that it actually produces a 0. So we get all excited and we say 0. So x minus 4 is a factor. That just helps us remember what we're doing, how it works with other problems. We're going to have our quadratic now of x squared plus 5x plus 4. And we're supposed to be finding 0, so we're going to set this equal to 0. We can factor this apart, and it clearly comes out to be what multiplies to be 4 and adds to be 5. So we can do our zero product property. So we get negative 1 and negative 4. And don't forget that 4 was also a factor. Now we're going to flip this over. Now we're going to get crazy. We're going to try to find a k value that fits the equation. Just a little puzzle thing. Kind of fun to do. So what is the value of k such that x minus 4 is a factor of this equation? So we're going to take x minus 4 and equal it to 0. So x equals 4. So you know what value we're going to use in synthetic. We're going to use our coefficients, which are 1, negative 6, our unknown number, and 12. So just like we would before, we would bring down the 1 and multiply, add the 2 together, and multiply. Unfortunately, I can't add these two numbers together. This is k minus 8. I don't know what that means. I need to know what k is. Well, if you look past it, I still don't know what we're adding together. But what do they need to add up to equal? It must add up to 0 if it's going to be a factor. So we know this has to be a 0. And if this is a 0, what number must be under the 12? It clearly has to be a negative 12. For this to be a negative 12, what number does 4 times what make negative 12? Negative 3. That multiplies to give you negative 12. So now you've figured out the number down here. Now you can figure out what number minus 8 gives you negative 12. And if k was 5, 5 minus 8 gives you negative, I think I said 12 there, I'm sorry. What number minus 8 gives you negative 3? And that's going to be, you could calculate it if you wanted to. K minus 8 equals negative 3. We're actually plusing the 8 to the other side. So you know k would have to be 5. 5 minus 8 gives you negative 3. So So your new equation would be 1, negative 6, positive 5, and 12. So you go ahead and try that with this last example down here. Pause the video, give it a try, come back, check it out. So we know that we're working with x plus 2 equals 0. So in synthetic division, our 0 is negative 2. Our coefficients are 5, negative 1, some k value, and 8. We're going to drop down the 5 just like normal and multiply. Gives us negative 11. Multiply to give us 22. I can't do that math. K plus 22 because I don't know what it's supposed to equal. Two unknowns. I know that this is supposed to be a 0, so this has to be a negative 8. Negative 2 times what gives me negative 8? Well, that would have to be a 4. So now I have k plus 22 that is giving me a positive 4. Minus the 22, k must be negative 18. Negative 18 and 22 gives me 4, and that looks right.